This is for pre-calc, the 231 group. Today we're doing 1.5, which means last class you just finished your quiz. So hopefully those went okay. Give me some time to obviously grade them for obvious reasons. So we're looking at Wednesday, September 30th, which is 1.5, which is intervals of increasing, decreasing, and constant. So I know I've kind of thrown a lot at you, even before I was out, and then, with that last, couple days before the quiz. So today's definitely an easier day. Hopefully you remember slope and stuff like that, but that's kind of what we're doing, related a little bit. So grab your graphing calculators. You can use those today, and, you do the warm up. So pause the video and do the warm up, and then resume the video when you're done. All right, so if we do the warm-up, we're going to have, the slope of that first one, which you don't have to do on the teacher pad since it's not open. But we're going to have, 15 comma 8 and 7 comma 2. So we want to find the slope between them. So if we remember, the slope is the change in y over the change in x. And we use that triangle, which just means delta, it just means change in. So I'm going to do 8 minus 2 over, those are the y's, 8 minus 2, 15 minus 7. And when you do it that way, you get something like 6/8, which is 3/4. So that should be the slope for that one. This one you would do negative 22 minus negative 3, which is negative 22 plus 3. So you get like negative 19. And then 5 minus negative 2, which is 5 plus 2, which is 7. So that would be your slope for that one. You can't reduce that. And it doesn't matter if you want to do 3 minus negative 22, you'd get positive 19. Negative 2 minus 5 would be negative 7. Same thing. This one, negative 11 minus negative 11 is going to give you 0. And then 5 minus 11 will give you negative 6. But anything with 0 in the numerator is going to be equal to 0. So if the slope is 0, that just means you have a horizontal line. We'll talk about those in a minute. And then finding your zeros on this, use your graphing calculator. So what we would do, I'll take this out. So you get 2x to the third minus 3x plus 1. So you would just do y equals, right, we got 2x to the third minus 3x plus 1. So minus 3x plus 1. And then you would see it's going to cross the x-axis 3 times, right? And you can certainly zoom in if you wanted to. Right? You can go window. You don't probably need to go. You don't need to go that far, but that's not the one that's important. Your mins can be like negative 3, and then up to 3, and that's all that you need to really find the zeros. So you can see it clearly crosses right here, and right here. So we can do second trace 0. And I'm going to get this one on the left. So it's asking me to go left bound. So I need to go left of that first 0, which I'm definitely to the left here. And then it's going to go to the right, right? So I'm definitely to the right now. And then guess, just hit enter. And I get negative 1.37, right? And I can do that same process for the next one. So left bound, go to the left of this one, enter, and to the left of it, but not going too far. And then enter, I get 0.37, and I think that last one is actually at y equals 1, but we can still do it, right? So we'll get to the left of it, but you don't want to be left of the other one, just this one individual one. To the right, enter, enter, and we get 1, right? So those should be your 3 zeros right there. So it was negative 1.37, 0.37, and 1. All right. So today what we're doing, increasing, decreasing, constant intervals. Right. This is kind of very wordy language, but it's actually pretty simple to kind of understand. A function is increasing on any interval for any x and x2 in the interval, as long as So x1 is less than x2, so it just means x1 is further to the left than x2. So if the y value of x1 is less than the y value of x2, it's increasing. What does it mean? It just means x2 is bigger than x1, so the y value is getting bigger, right? So like from here to here, right, you're going up. That's literally all that it means. It's really heavy language for something pretty simple, right? So if the graph is going up from left to right, you're increasing. If it's going down from left to right, like this one is, you're decreasing. If it stays the same, it's constant, right? It is that simple. So if I said something like, well, actually, let me take this one for example. Right, so this one is one that we kind of want to look at. So a typical question will say, label intervals of increasing, decreasing, and constant. So what we would want to do is just say, okay, well, it's going to be increasing, decreasing, and constant. So we would say that it's increasing and you're only looking at the x values. It does not matter if the y value is 1. It has nothing to do with the intervals of increasing, decreasing, right? So it's increasing from 2 until 4 and then it stops. So we're going to use like interval notation here. We're going to say increasing from 2 to 4. And you always use parentheses here. You're just never going to use brackets with increasing, decreasing. So even though it's like included, it doesn't matter. Always parentheses with intervals and increasing and decreasing and constant. So decreasing, it's decreasing from -2 until you hit 0. So we're going to say -2 to 0. And then constant from x equals 0 to x equals 2. So 0 to 2, right? And that's everything. So next, we'll take a look at this one, right? This is x to the third, right? So if we wanted to do increasing, decreasing, or constant, it does kind of look like it's constant right there, but it's not. I mean, it's always going to be going up. If you think about, plugging in numbers for x, they're always going to be going up. So how do we say increasing? Well, since it's always going up, it's always increasing, right? It's never decreasing and it's never constant. So you could put decreasing and, that little, something like that. It's never decreasing. It doesn't exist. There's no decreasing intervals. So that one is always one that increases. Now, if we drew it the other way, we want to draw it this way, then it would only be decreasing because left to right, it's always going down. And you would flip these two, it would never be increasing. All right, next one. Right, so here we have a graph that starts by increasing. It hits kind of a high point, but just a relative high point because the high point is infinity because this arrow is going to go up to infinity. Right, and then it starts to decrease until it hits a low point, and then it starts to increase. So these high and low points are what we call relative maximums and relative minimums. So right here we have a relative minimum. Right, the whole minimum is still infinity because that goes up forever. But the relative minimum is -1, 2. And if I ever ask you for a relative minimum, you do give me the full coordinate here. And this is the relative maximum, and this would be your relative minimum at 1, -2. Right. So if we wanted to do increasing, decreasing, constant again, decreasing, it's never constant, so we'll just leave that alone. So increasing, if I start all the way to the left, negative infinity, it's always going to be going up, 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 until you hit the x value, right? We're not worried about the y values for increasing, decreasing. So increasing from negative infinity to -1, negative infinity to -1. But then you see another one, right? It's going to start increasing again right here at x equals 1 over to infinity, right? As long as I keep going right, it's going to keep going up. So I need a union symbol, and then from 1 to infinity. Right? So that's the intervals of increasing, here and here. Now, in between here, right, this little section, that's where it's decreasing, so we only need to say from -1 to 1. Again, ignore the y values. It's a common mistake. Just make sure you're ignoring those. So it's -1 to 1, and that's it, right? You've covered all your intervals. You have -infinity to -1, then you have -1 to 1, and 1 to infinity, which is perfect, right? That's a quick check that you can do to make sure that you're covered, right? Every x value is covered, you're good. So, and again, these are relative minimum, that's a relative max and a relative min, right? If I ever ask you just for those, you would want to give me the full coordinate, in which case you do want the y, but these intervals, never. This one you can do on your own, so just pause the video really quick. Give me increasing, decreasing, and constant intervals. Okay, so if you've done this one, if we take a look at it, we'll just label these really quick. Increasing, decreasing, and constant. Right, so increasing, right, from left to right when it's going up, that's going to be -infinity because you got the arrow right there. So -infinity up until you hit this x value, which is 0, right? Not 1, doesn't matter that the y coordinate's 1. So we have -infinity to 0, and that's it. It never increases again. Constant is going to be from 0 until x equals 2. And your decreasing is from x equals 2, and since the arrow's going, you're going to go to infinity. And that's it. Again, you're covered. You got -infinity to 0, 0 to 2, 2 to infinity. That's everything. And then you have some examples of trig functions, which, just to kind of show you quick graphic. Let me see here. We want to just go to, a polynomial, right? So if I had a quadratic function, which we will eventually get to, I think. There we go. All right, so we have a quadratic, right? So a quadratic, if you want to think about sliding this, right? The vertex is what's going to be the relative minimum here. It's the overall minimum too, but it's still a relative minimum. So until you get to the vertex from here, you're decreasing, and then after the vertex, you start increasing. Now, if I wanted to make this a much more complicated polynomial, the quintic, so the degree would be 5, right? This is certainly a little bit more difficult, right? So from -infinity up to, it looks like, x equals, -1 almost, maybe a little bit less, a little bit more. You would be decreasing, increasing, decreasing, right? It's kind of going through the whole thing. So it's increasing, and then it gets to that point, and it starts decreasing. Then it gets to that point, it starts increasing. Then it gets to that point, starts to decrease. Then there, I missed it a little bit. But then from here on, it's going to increase. So literally, you're going to have an increasing interval from here to here, from here to here, and then from here to here. There's 3 different ones. Decreasing, you'd have from here to here, and then from here to here, you'd have 2. So your relative maximums, right? We talked about that before. That's one of them, and that's the second one. Your relative minimums, that's one of them. That's the second one. So you have 2 relative maximums, 2 relative minimums, 3 intervals of increasing, 1, 2, 3, and 2 intervals of decreasing, 1 and 2. Okay? You don't want to say that. All right. So definitions of relatives, mins, and relative maximums. Again, kind of wordy here, but all I really want you to know is it's kind of like a local high point or local low point. Sometimes you do call them local maximums or local minimums. But really, it's just kind of like where is there like little vertexes throughout the graph if there's more than one. So this would be a typical problem you guys would see. I want you to do it on your own. Use your graphing calculator. Find the local minimums and maximums. Find the intervals of increasing, decreasing, or constant. And then part C, find the zeros. So go ahead and do that on your calculator now. All right, so what we should have found, 0.5 x to the third, 0.5x to the third, and then minus 7x plus 1, minus 7x plus 1. All right, so if we graph it, that's the graph you should have gotten. You're probably just going to go zoom 6. So I get my window back. All right, so what we see here is we can't get this maximum because it's off the graph a little bit. So I'm just going to change my window and make the y a little bit higher. So it was that my y max was 10. I think if I probably go 15, I'll get that top part, right? And I did, okay? So first part, maximums and minimums. Right there I have a local max, right there I have a local min, so I gotta find them. So if I do second trace, I'm gonna do the maximum button. So, and then it's gonna be the same thing as a 0. I need to go left of the maximum. Right, definitely to the left. Whoa, it's just, okay, that was weird. Still definitely to the left though. Then I need to get to the right. All right, definitely to the right. Enter, enter. You know, and I get something like negative 2.16, 11.08. So, part A. So I got negative, oops. 2.16, 11.08. That's my maximum, and you'd want to put max next to it just so, you know, I know that you know which one it is. And then your minimum, you're going to do second trace, minimum this time, so I'm just going to hit 3. And it's going to ask me the same thing, left bound, so I got to get to the left of the minimum, which actually you already are. So you can just hit enter at this point. And then right bound, right, I'm definitely to the right. And if I hit enter again, I get 2.16, negative 9.08. So I'm going to have, you know, my minimum at 2.16 and negative 9.08. All right. Part B wanted the intervals of increasing and decreasing. So those maximum, minimum, those x coordinates are going to be come in handy. So increasing, I'm negative infinity, right? I'm going up from left to right. Negative infinity up until I hit this x coordinate, which is the same thing as the x coordinate of the maximum, which I think was negative 2.16. So I am negative infinity to negative 2.16. And then take a look at the graph, see if I'm increasing anywhere else. Yeah, I am, right? So from this x, which is positive 2.16, up to infinity, right? All the way over to infinity, I should say. So I'm going to say union, and then 2.16 to infinity. And then that's my increasing, which I probably should have labeled it as increasing. Decreasing. If I can get there. All right, not really cooperating. Do it this way. So decreasing, if we take a look at the graph, right, it's just in between. So negative 2.16 was this x to positive 2.16 at this x. So I have negative 2.16 comma to positive 2.16. And that's the only thing where it's decreasing. There's no constant. It's never a horizontal line. And then part C was just, it asked me for the zeros. So we'll just do what we did in the warm-up. Second trace, zeros, and going to take a little while to get there. Kind of dragging behind a little bit. Again, now, I don't know who you had last year, but some of you may have used the intersection button to get zeros. You still can, just make sure you do y equals 0 as a different one. I just go left bound and right bound though. So here I have negative 3.81, so negative 3.81, and when in doubt, use the hundredth. You know, most of the tests and quizzes will ask you specifically, but when in doubt, use hundredth. So that's what I'm using here. All right, so now I need the second one. Looks like it's at 0. I'm sure it's not quite there, but probably close. So I'm definitely to the left. Now you go to the right. Okay, I'm definitely to the right. Hit enter, 0.14. So 0.14, 0.14. And there's one more. So you have to second trace 0 all over again. All right, to the left, to the right, and I get something like 3.67, and this is not 0, but really it is 0. Your calculator just kind of thinks itself stupid, right? This is 2 times 10 to the negative 12, which is like 0.000000002. So for our purposes, it's 0. Don't panic if you see this, it's 0. So 3.67. And that answered that question. And this is a typical question which you'll see on an assessment, right? Increasing, decreasing, maxes and mins, and zeros. How does this work in real life? Well, I had this, but it didn't work the last time I opened it. Yeah. But it's this app called Linebird. Somebody said there's one called Featherbirds. I'm sure it's kind of the same thing. But
hey guys, this app review is going to be on the amazing game that has became like #1.
Not
it's not free
easy.
anymore. I don't know how tutorial. This game is very easy.
So you can kind of see the bird right here.
Bottom right hand to go over
every time he taps, right, the bird goes up and down. So really think of this as just a giant increasing, decreasing interval, right? A giant polynomial that's going up and down and up and down. You know, increasing, decreasing, increasing, decreasing, increasing. Okay.
So let's try one of the abilities. As you can see,
but it kind of works just like that, right? So this bird is like always increasing, always decreasing, and you know, thank God you don't have to do that as a problem. But you know, these kind of things exist all over. You think about, you know, Mario jumping or double jumping or anything like that. It's increasing and then decreasing. Those parabola shapes, they happen all the times in video games and you know, all sorts of stuff. So that's one example of it. So what you guys want to do is break up into your processing partners. Let me see here. You can get with, see if you have one like increasing and decreasing. Nah, you don't. Why don't you get with your, you know, your piecewise processing partners. So take a second to take those out, sit with them, and what you guys are going to do is the 1.5, not that one, increasing and decreasing. It's not really a worksheet, it's more just like a classwork. So, you know, there's peaks and valleys, it goes through all this stuff, x to the third minus 4x. It's on Schoology. You didn't have class notes today, so this is just on Schoology in your classwork activity. Right, it kind of gives you a problem, and then if you scroll down to the next page, it kind of gives you the answer. So just kind of fool around with this page, get your answers with your partner, and once you're done, all you want to do is this one problem, right? So once you're done, do this as your exit ticket, and see if you can get the intervals of increasing, decreasing, and constant, and then the local maxes and mins. And you don't have to worry about this. Again, it's not going to be on the answer pad, so just kind of do this on your own. After that, you are done with the lesson. If you wanted to start the homework, which is posted on Schoology, but also right here, go for it.